Good morning, good afternoon. Welcome to the joint Grantek and Systec Solutions webinar covering the topic of HMIs in clean rooms. My name is Jan Thriene, and we will be speaking a bit about myself through clean rooms, clean room contaminations, and then we will go into detail on the HMIs features that you need to look for when putting HMIs in clean rooms, and a bit of general information in regards to that. Any questions that you might have during the presentation that come up during the presentation, please send an email to info@grantek.com, and then my colleague Jeff and also Mike and also Alicia will then forward those questions to me, and then we'll be able to answer those towards the end of the presentation. Also, one note up front, we will be at the ISPE Boston Product Show next week on September 26th. We will be delighted if you drop by and visit us at booth W94. Okay, so let's get started with our webinar on HMIs in clean rooms. And as I said before, a few words about myself. I'm the responsible business development manager at Systec Solutions. We are based in Karlsruhe in Germany, therefore also the German accent. And we produce GMP-IT hardware. That means it is specialized hardware that is being used in clean rooms, in FDA regulated areas, or in any areas where there are special requirements in regards to hygienic cleanability and things like that. Myself, I've been in the business for over 7 years now, serving pharmaceutical, food, cosmetics industries, and I've been a bit around the world, been in China, Europe, and have been working for various American companies as well. So we'll start with some basics to make sure that we are all on the same level when we talk about clean rooms. So what is a clean room? It's a controlled environment with a very low level of pollution. It's used in manufacturing and scientific research areas. There are three standards that define a clean room. One is the ISO 14644-1, which classifies the clean rooms into ISO 1 to 9. Then we have the European GMP standard, which defines them from grade A to D, and which is also the standard that we usually use in our materials. And then there's also a British standard, BS 5295, which classifies clean rooms from class 1 to 4, but that standard is actually very seldom used. So for a clean room, airflow, air filtration, and particle size are key criteria for any clean room designs. There are very special requirements for any equipment going into clean rooms. And even though clean rooms are used in many different industries, our focus for this presentation will be on the bio and pharma industry. So one of the key issues in clean rooms is microbial contamination. That's really the main concern in the pharma and bio industry. And traditionally, there has been no technology to directly measure microbial contamination in real time. So what happened was that all airborne particulates were used and extrapolated to be a representative of possible microbial contamination risk. Those viable organisms require support to sustain in the environment, and microbial spores, bacteria, and viruses cling to the surface of non-viable or inert particles. So what are the sources of these contaminations? And there are internal and external sources for that, and those include, of course, the area personnel, and that's actually also the greatest source of contamination. So people working in the area, in the clean rooms, they are usually the people or the sources of that contamination. The manufacturing process itself might add to contamination, the processing equipment, any items that are transferred into the clean room, either from another clean room or outside. Bringing in stuff from another clean room also adds to the risk of cross-contamination. Utility service lines might add to clean room contamination, and of course paper. So when you have a special look on the processing equipment, which is kind of also the direction we are going with this webinar here, it releases mostly non-viable particulates even after validated cleaning. And the cleaning activity, due to the demanding nature of the cleaning process in itself, may release large quantities of particles during the cleaning process. So when you look at that, you have all kinds of sources, but again, the largest source for contamination or for those non-viable particles is usually the area personnel and also paper. When we look at the HMIs, they are mounted into the clean room to really support the processes. They are required for all production steps in the pharma and bio industry to control the processes, to visualize the processes, execute the processes, and to also validate the processes. And of course, they are a must-have for any paperless documentation. So when we talk about those HMIs being used in clean rooms, we look for very special features. And keeping in mind that you don't want to release any non-viable particles into the area, you want to have something with a stainless steel housing. So stainless steel serves there two purposes. One, it does not release any non-viable particles, and the other one is it's there to withstand the cleaning agents. You need a smooth stainless steel surface. That roughness is ideally below or equal 0.8 micrometers. So you get that with a 240 Cornish surface finish, or when the surface is really treated with glass beads, for example. Another thing is no rough edges. That's usually not really a key criteria, but it helps in preventing any harm to the operators of the HMIs. No grooves, so no product, no particles can really settle in grooves, and usually they're also very difficult to clean. The whole design must be really made for easy cleaning, so no sharp edges. Any area is easy accessible by hand and to be able to be wiped down. No open ports. That's one that we will go into later on in a bit more detail. Silicon as a gasketing material. If you use stuff like rubber foam or any foamed gaskets, you may notice that they either deteriorate because of the cleaning agent or simply because of age, and then they will just fall apart. Then the whole IP rating for the solution should be IP54 or better. Ideally, it's an IP65. And the reason for that is you just take your cleaning agent, you spray the unit down, you wipe it down, and then you clean it either with a bit of alcohol and water, and be done. You don't want to worry about whether any of the cleaning agent goes into the electronics or into the keyboard, stuff like that. So you just don't want to worry about it. So anything which is IP54 or better is really suitable for an industrial environment. So the overall system should be designed to prevent the accumulation of fluids and also the collection of dust. And as I said before, the mechanical design needs to allow easy cleaning, safe inspection, and and simply to make sure that everything is really easy to clean. Another thing is that the display and the industrial PC that comes along with it should be integrated into a single housing to really allow that there are no gaps, no grooves, no front bezel from the display, and again that everything is IP54 rated or better. Some of the units or some of the HMIs do offer a laminated safety foil for the display, and this is a security feature depending on where the HMI is mounted. It's really there to prevent that if something happens to the HMI, someone damages the front glass in whatever way you can imagine, that no glass shards really pollute the product. So the laminated safety foil is there to prevent exactly that. It's usually a requirement that you see in the food and beverage industry, especially for dairy products, baby milk powder, I should say. But it can also be applied for any HMI that is close to tablet coating machines, tablet pressing machines, stuff like that. Also, we promote an integrated PC into the housing with an industrial design of the IPC. And the reason for that is stainless steel is a very bad thermal conductor. So the heat tends to stay in the housing, and for that kind of environment, you really need an industrial design of the IPC to withstand those higher ambient temperature ranges then. It's also important that you have no active fan outlet, so that the graphics card or the fan of the CPU does not pollute the environment. So that together then forms a certain HMI. So, but you also need to enter the data, right? So for that kind of activity, you prefer a keyboard simply because it's easier to use rather than a touch screen. And a lot of the software available for the process control, for process visualization, is not really designed for touch screens. The reason for that is that a lot of the processes, at least on the distributed control systems, is made for central control rooms. Those central control rooms are equipped with office PCs, of course, and the design is then not really for touch screens in the field. So a keyboard is reasonable. Keyboard should meet a hygienic design. No external wires, because the wires again is a source of non-viable particles. No external connectors and ports, and I will go into that specific issue in a little bit. Stainless steel housing, because the same rules apply. You need to make sure that it withstands the cleaning agents. You need to make sure that it does not further pollute your clean room, and IP54 or better is very, very good for that kind of application. The best haptic feedback you get is from a foil keyboard, or a membrane keyboard, I should say, and the best cleanability is from a glass keyboard. And the reason why I mentioned those two keyboard styles is really that it depends on your application what kind of keyboard you should really look into. If you want a haptic feedback and do not have a lot of data to type down and not a lot of data to enter into the system, then a membrane keyboard is probably perfectly fine. If you need to enter a larger amount of data, then the glass keyboard is the better choice, simply because the membrane keyboard requires a certain amount of pressure that you apply to the buttons. So you get that sort of mini hub keyboard where you press the button and you need a certain amount to push it down. The glass keyboard is just a simple tip of your finger, like you know from your tablet PC. Which gives you not really a haptic feedback, but because the glass keyboard is printed from the rear, the top surface is really just glass, and that makes it really, really nice to clean, very easy to clean, very sleek and elegant design as well. So those kind of keyboard solutions are in the market. Those are the ones that we recommend, then depending on your application. And of course, you can have a really nice solution, but it has to be integrated into the existing IT infrastructure. That starts with the physical layer support. So you have multiple LAN ports to support a redundancy scheme if you have one, dual band Wi-Fi, standard LAN and USB connectors. So you don't need to get someone to change any cables, cut off any connectors and put a special connector on it. You need to have the system supported by a local IT standard. So the question then really goes with what kind of operating system do I use for my industrial PC? Is it a standard Windows? Is it a customer specific image that needs to be installed? Do I have a special operating system for Thin Client, like the Ideal Thin Client or the Thin Manager, or something completely else? You need, for example, also KVM, keyboard video mouse extender support. And last but not least, the HMI always works in conjunction with third-party equipment. That could be a biometric scanner, a card reader, Bluetooth scanner, and also a printer. So in the end, you have a lot of individual parts that then in the end form a single system. And you need to make sure that all those single parts meet your clean room requirements, or at least make sure that that they're usable in that clean room. And based on that system, you need to make sure that also the software side works, and then you have a full system that you can put into your clean room. There are certain challenges, and the key challenge that we know from our customers is always cleanability. And the worst case scenario that you can have is office equipment. If you put a Dell laptop, an HP laptop, any kind of standard office equipment into a clean room, it's really a no-go. You have an active fan, you have plastic surfaces, grooves, edges, foam rubber gaskets, open cables, exposed connectors, exposed open ports, and unclean cavities. And I selected this picture on purpose that we see here because you have those two operators dressed up nicely, all taken care of, and then you see certain issues. You see the keyboard is a standard office keyboard. That's the kind of keyboard that after 2-3 weeks in the office, you turn it around and a lot of stuff falls out. You see another issue here with one of the operators having his private phone connected to a laptop. And again, that's a key issue that we need to address. And you have those screens that are not suitable. You have a mouse mat actually in the clean room with a standard office mouse. And even though it's nice and it's more convenient for the customer, but it does not meet any clean room standards. Another solution that customers also use is healthcare or hospital equipment. And it is an improvement because you have then at least hygienic keyboards. You have IP65 rating for the front panel. You have an antimicrobial surface and less edges. But as you can see with this picture, you still have grooves, you have exposed cables, plastic surfaces, and it's really difficult to clean when you have short cleaning intervals. And if you take a look at that picture, the mounting arrangement is actually quite nice, I have to say that, but with the cables being exposed and cables running really wild, you would not want to be the person who cleans that. And if you have to be the person that cleans it, you will spend a lot of time going through each and every cable, wiping it down, cleaning it properly, putting it back together. So from an operational standpoint, that really is a nightmare. And then best case scenario is something which is really designed for clean rooms. That means it's IP65 rated, smooth stainless steel surface, no grooves, no edges, no front bezels, no exposed connectors, and all the cables run internally. So there is no rubber cable or plastic covered cable running outside that you need to wipe down. It's all hidden inside. There is no USB cable anywhere. There is no mouse with a piece of cable to it. No extra cable gland that you need to worry about. So that would be really the ideal solution. And just to give you an idea, cleaning one of those units that you see here takes about 4 to 5 minutes, and that's really proper cleaning. With all various edges that might be there, wiping every surface down. And if you look back at the hospital equipment, you would be probably at least at 45 to 50 minutes, just to make sure that each individual cable is properly wiped down. So you know best what an operator costs, and spending that additional amount of time on cleaning rather than more useful jobs or activities is costing you a lot of money. And that's one of the key points really of selecting the right equipment for your clean room environments, to make sure that you save money, and you can do that really by selecting the right equipment for that kind of environment. Security features, so open ports, and I think the standard to everyone is really the USB port. Everyone knows a USB port, everyone needs a USB port. You can connect all kind of equipment from an external CD drive, if you still use that, USB sticks. You can charge your mobile phone over it. There is no life in modern IT without a USB port anymore. But of course, those kind of USB ports are a security risk, and there are really bad examples in the meaning of that it really costs companies money when people find a USB stick in the parking lot and want to make sure that they return it to the right finder, or to the right owner, and put it into their company PC by trying to be really good finders, and then you have the issue that some firmware or some malware is actually loaded into your PC and the whole system is infected. There have been examples of large pharmaceutical companies that were affected by the WannaCry malware, where whole sites had to shut down. The whole IT system needed to be wiped out and rebooted from security or from safety points. So it's no fun, and it really is a huge risk. We also have customers where when you walk through the clean room, where mobile phones are being charged over standard USB ports because they are using standard off-the-shelf laptops in their production environment. Those are the kinds of behavior that you see. and no matter how good your SOP is, if it's not being really driven down to that level, you will have that kind of behavior. So any open USB port is a security risk, and it's very difficult to clean. You need to use cotton swabs, basically drenched in alcohol, to clean any port. And it gets even worse than if you go then to VGA ports or audio jacks, these kind of things. So a good solution is to cover those USB ports to prevent an easy access, and that's what you see on the picture here. But the best solution is really to have no external USB ports, because they're either there is no need, because you have, for example, no USB cable scanner, but rather a Bluetooth scanner, or because all the cables are internally, so you have no need to put a USB keyboard to the system, and these kind of things. So that's really the best case, to have no accessible USB port. But that is something that you need to keep in mind, and the next time you're walking through your production, you might want to keep an eye open for these kind of things as well. Going a bit further, special case tablet PCs. There is a large movement in the industry to move towards tablet PCs. Why is that? Because they are cheap. But they have the same challenges as any standard equipment. So they have open ports, they have push buttons, they have active fans, they have exposed interfaces. These kind of issues exist, and they also pose some additional challenges. So a tablet PC needs to be charged. Where is the place of charging in your clean room, or is it outside your clean room? Is there a docking station? If so, who is cleaning it? How do you clean it? Especially with all those exposed connectors. You have exposed cables to the docking station, a power supply that needs to be plugged in somewhere. These kind of things you need to keep in mind. A tablet PC is also highly mobile. So you can move it easily from one clean room into the other, into the next, and that poses really a higher cross-contamination risk. So the importance of cleaning it properly between the individual clean rooms, or moving it from clean room to clean room, is really high, and you need to make sure that you do it properly. And the less designed it is for these kind of environments, the more difficult it becomes. Also, because it is so highly mobile, it's easy to move around, and there is a higher risk of a tablet PC of being misplaced. So if one of the operator kids might need a new tablet PC, he might get one from a specific tablet, from a specific clean room, and then that tablet is gone. Also, product lifecycle is something that you need to think about if you are looking into tablet PCs. They are usually simple commercial products. Lifecycle is about 2 years. So if you decide for a tablet PC, then you might end up with 2, 3, 4 different generations within a short time frame, and also the financial depreciation period for a tablet PC is much shorter than for standard office equipment. So if you use it in a production environment, you are usually not getting your 3 or 5 years out of a tablet PC. You might get 1, maximum 2 years. These are kind of things that you need to keep in mind, that you need to consider. I'll be talking about that topic in detail at the ISP Boston show. So if you're in the area, make sure you sit in on that specific session as well. Also for mobile systems, is what we call our trolley solution, and there are two mobile versions that are most common. One is a healthcare-based trolley, and I will go into that in the next slide, and then a GMP-based trolley. So again, they face the same challenges as standard equipment with an added difficulty. The surfaces need to support the GMP requirements that we've talked about before, with the smooth surfaces, no edges, no grooves, no front bezels, easy to clean, easy to wipe down. But also because they are mobile solutions, they are battery powered. And those batteries should support at least 2 work shifts. So you're not constantly moving this thing out and into the clean room again after recharging it. So you need to make sure that it really lasts a certain amount of time. Excuse me. And it also needs, because it's being moved into and out of clean rooms, it needs clean room wheels. So they are special wheels that are very easy to clean, where there is no tight gap between the actual wheel and the support arm that holds the wheel in place. So there's a special gap, so you can actually move your finger in between and properly clean it there. Cleaning effort for a validated cleaning, a healthcare trolley, and I will show you that one in the next slide, takes about 50 minutes, and that's based on user experiences. And the trolley that you see here in the picture on the left-hand side, cleaning that one, you talk about 5-6 minutes usually. And again, that's really wiping it down properly, cleaning all surfaces, everything. So again, it takes a lot of time to clean a non-hygienic designed product versus something that's really designed for those kind of environments. So here we see the example of a healthcare trolley. That kind of product is really optimized for the use in hospitals. It contains an uninterruptible power supply or a small battery pack for a single shift. So that means you basically roll it into the room when your shift starts, and then after the shift, when you're done, you roll it out, and the next shift needs to roll another unit in. You can see from that picture really that you have many difficulties when looking at that kind of product. You have plastic surfaces, you have exposed cables, grooves, open and exposed ports again, external wires, ventilation slits for an integrated PC, which is then again only an office equipment system. So a temperature range from 10 to 30 degrees Celsius. When you put that into an enclosed environment, that unit gets much warmer, and that leads to a shorter lifetime. And then again, I think you can see here those plastic wheels, there is no gap between the wheel and the supporting arm. That kind of wheel is very difficult to clean, again with cotton swabs. So the person who needs to clean the unit is really busy for a long time. And if you think about that one lasting only one shift, so if you have a 24/7 operation, you need at least 2 of these per clean room, per operator. So you need a lot of those trolleys, and you need to spend a lot of time in cleaning those items. So again, I have to highlight that you need to really look for those kind of products to be designed for use in clean rooms, to make sure that you don't pay the sort of cheaper price at the beginning than in the operating cost. Also, in regards to cross-contamination risks, what you see in the top picture is a magnetic USB cable. a magnetic USB connector with an attached cable. That kind of connector is IP65 rated, so you can really spray it down with a cleaning agent and clean it properly. So charging in the clean room is not really an issue. But of course, power cables and rubber connectors do pose a cross-contamination risk in the clean room. So you want to make sure that you don't have to run any power cables, USB cables, Ethernet cables, these kind of things through different clean rooms without properly cleaning it to reduce the cross-contamination risk. Also, as I said before, exposed ports, any data ports, USB, Ethernet, Apple Lightning for people that like the iPad, video ports, display port, HDMI, VGA, they are a nightmare to clean properly, and you can't really spray them down with the cleaning agent because you might damage them that way. And then also the docking ports, what we talked about earlier, for your tablet PCs. Also cavities, anything behind ventilation slots or behind maintenance door is usually unclean, and opening up that kind of unclean cavity does pose a certain risk to the clean room. So looking at the picture on the bottom left, this is our solution for removing any power cables from the clean room. It's an inductive charging mechanism for our mobile systems. So that way the unit can be moved freely within the clean room and does not need to go out of the clean room for charging anymore. And the docking station can be mounted either onto the wall, but there's also a flush mounted version. Then of course, in a production environment, you need to label or you need to print a label, whether that's for a certain batch you're doing, if you need to label a certain container. So you have then the choice between a thermal transfer or direct transfer technology. It's mechanically highly complex equipment. It's not designed for clean room applications at all. And if you want to clean that kind of equipment, it requires a huge amount of effort. And at the end, when you're done cleaning it, you might have a couple of parts left over and you don't know where do they go again. So our solution for that kind of label printer, whether that's a large one that you see here or a smaller label printer, is really to put it into an external housing with a label dispenser. So into a stainless steel housing, to make sure it is within a controlled environment inside the clean room. So it's a stainless steel box with a glass door, where you put the printer inside. You have a little glass door at the front so you can see that the label has printed correctly. You open a small glass door, remove the label, close the glass door again. That way not the whole printer is exposed to the clean room. And then also the tests that were done in regards to printers in clean rooms show that during the printing process, the contamination of the room is really the worst, and as soon as the printing process stops, then the particle pollution settles down because all the particles from the printing process settle down. So once the printing has stopped and then you open up the door, it is not as bad as if you would expose the printer the whole time to the clean room. Also, with that slide out drawer, you can then remove or replace the paper drum inside the printer. I admit it's not a perfect solution. There is still pollution to the environment, but it is a significant improvement to having a printer just standing in the clean room and polluting the whole thing the whole time. So that is one solution that we that we add to the HMI system because it's part of the IT infrastructure. The other one is really barcode scanners, and with the serialization, with batch control and everything runs with a barcode. So every time you do something, every time you weigh something, you put something on a scale, you need to scan a barcode. And therefore, the barcode scanners, again, are industrial equipment. There is a much better or much more improvement in regards to the design than what we see with the label printers themselves. Means that the scanners are, if you look at just the hand piece in itself, easier to clean than the whole scanner cradle. So therefore, we are looking at two solutions basically. One is the simple handgun connected to the HMI through a Bluetooth connection. And the second one is where you have the scanner cradle connected to the HMI through a USB connection, and then the scanner cradle provides the Bluetooth connection to the handpiece. The scanner cradle is there to recharge the scanner, which was the case in most applications where the scanner has an integrated battery pack. But the problem with that kind of solution is that the scanner cradle is usually rated as IP20 maximum. So your whole system degrades from an IP65 or IP54 down to IP20 because that's the weakest point. And again, the scanner cradle is a really pain to clean it. Again, cotton swabs, you can't spray it down properly. You need to have or you have issues with really cleaning all the nooks and crannies in there. And again, a solution would be to put it into a separate box. That way the scanner cradle is not not collecting any dust, not really posing an issue to the clean room. But the better solution really is to have a scanner with a removable battery. And newer generation scanners provide that from various manufacturers, where there is a small capacitor inside the scanner gun that keeps the pairing between the HMI and the scanner alive while you swap out the battery. So that way the scanner gun is IP54 or IP65 even, no degradation to the overall system, and you can really spray it down, wipe it down, and just use it as you like. And then the battery pack is charged, for example, in those scanner boxes, where we can, for example, charge up to 8 batteries at the same time. And then that way you can run your scanner through your shift and the next shift and the next shift. So that is really the easiest way to move that forward. And scanner, label printer, HMI really form a whole set that you then can integrate into your clean room to control your processes, visualize your processes, and use it for your distributed control system or your manufacturing execution system or various other applications. So what are the key takeaways from this webinar? One is that the ease of cleaning is the key criteria for any equipment going into clean rooms. It has to be physically easy, it has to be time and effort optimized, the surface material need to be optimized, and you can use any common cleaning agent if it is a proper stainless steel housing. That's why the stainless steel housing is superior. You need to make sure that your HMI solution is fully encapsulated and at least IP54 rated. You need to have either hidden or protected standard ports for data and video. Your HMI must fit your application. Means that if it is something that requires a larger screen size, then you shouldn't go for a tablet PC. You should go for a real HMI, either fixed installed or mobile, and you need to really consider also the accessories. So it doesn't help if you put a fine, perfectly fitting HMI in there, and then the label printer makes all your efforts or proves them in vain, basically. So those are the key takeaways, and I've received a couple of questions from the audience, and one of the questions is, what is the battery life of a trolley? The solution that we offer has two battery sizes. So one is with 56 ampere hours, and the other one is 107 ampere hours. And then depending on the kind of HMI screen size you use, the IPC that you put into the unit, and the intensity of use through a shift, the 56 ampere hour battery lasts at least 13 hours, and the 107 ampere hours, 107 ampere hours battery pack up to 20 hours. So you can easily work 2 shifts, maybe even 3, with those different trolley solutions. Another question is, what differentiates Systec and Solutions from its competitors? Well, I think if you work, or if you have worked with Grantek before, it is certainly the strength and the competency of our partners. It is also the range of products that we have. They are designed for cleanroom applications, where we have those demanding requirements in mind, where we get constant feedback from our customers, from their applications, to improve on our products, to address needs in this specific niche of the market, if you want to put it that way. The quality of our products, everything is industrial grade material. So it's higher temperature ranges or larger temperature ranges, shock and vibration resistancy, longer MTBF times, these kind of things. So the quality of the products is very high, and I think our service is really superior. And it's not just that we supply you with a product or a component. We want to provide you with a solution. So we support you in a pre-sales role, where we also visit you on site, where we go through your production area together with you, determine what kind of HMI makes sense, where does it need to go, what kind of solution is the best for that kind of area, what is the best solution for that kind of application. So we really help you selecting the right solution for your application. And I think that's a service that not many of our competitors are able to offer. I hope I answered that question to your satisfaction then. And also the third and last question is, would you recommend a trolley or a tablet as a mobile cleanroom solution? And that will be a topic that we explore really at the session at the ISP Boston product show next week. But to give you a shorter version and sort of final line of that kind of question, it depends on your application. A tablet is a fine solution. We offer to put a standard off-the-shelf, say Microsoft Surface or a Lenovo tablet PC into a stainless steel housing to make it cleanroom suitable. But the kind of applications where we see a tablet as making sense really is for quality control, maintenance work, any checking of equipment, any application where you need to put or where you need to take data with you into the clean room, where you don't want to take paper with you, where you need to put, or where you take manuals with you into the clean room to set up a machine, stuff like that. There it really makes sense to have a tablet PC solution. A Trolley is a mobile HMI that is really for continuous process work, that is for batch processes. So that's really a production unit. So that way you have a proper display size. You have something where you can put your scanner that leaves you your hands free if you have to. A tablet PC does not. And we have customers that use a tablet PC in conjunction with a scanner. And it's a nightmare for the operator, because you can imagine holding a tablet PC for a large amount of time makes or gives you issues because it's so heavy. Even though at the beginning it doesn't look that way, but it's the same with a glass of water. If you hold it in your arm, after a while it becomes heavy. And if you use a scanner, on the other hand, what does it leave you to enter your data? The other thing that you need to keep in mind is that if you use a tablet PC and you want to enter data, the on-screen keyboard takes usually about 1/3 of your screen size away from you. So that makes it really difficult to read what's on it. It makes it difficult to enter your data, to see what you enter. So again, for quality issues or quality control, maintenance work, preventive maintenance work, a tablet PC is a fine solution. It certainly has a right to be in a clean room environment if you put it into the right enclosure. But a Trolley with a full HMI, with a full keyboard, with all those interfaces and features that it offers you, is a much better solution for a production environment. So I hope that that answers that question as well. And that also brings us to the end of this presentation, this webinar. And if you have any further questions, any requirements, if you want to know more, then please send us an email or give us a call, and then we would be more than happy to answer your questions, or to come by with a demo unit, explain the features to you in more detail, and take you through any steps that might be necessary for you to select the right solution for your application. Okay, then thank you very much for your attention. Thank you very much for your time. Thank you very much for enduring my German accent. And I hope you have a nice day. And then I also hope to see you next week at the ISP Boston show. Thank you.